Hello everyone, myself Ankur Patel, and today in this third section of solid, we will continue our practice with problems of section of solid. Today we will take a horizontal section plane as a cutting plane. So let us see the problem. So the given content regarding the problem is a cone diameter of base 50 mm, height 80 mm is resting on HP on one of its generator with axis parallel to the VP. It is cut by a horizontal section plane passing through a point on the axis 50 mm away from the apex. Draw the elevation and section plan of the cone. See, in the previous two examples, we have take the section in the first stage of projection of solid. But in this example, we have to define the second stage also, and we will take the cutting plane in the second stage. So first of all, we will derive the projection of solid. That means we will draw the front view and top view in the first and second stage as per the given conditions. So here, first of all, if you want to derive the first stage, we have to assume some data by using the given conditions. So here it is given that the cone is resting on HP on one of its generator. So if the cone is resting on horizontal plane, then in the first stage we have to assume that the cone is the base of the cone is parallel to the horizontal plane, perpendicular to the vertical plane, and axis perpendicular to the horizontal plane, parallel to the vertical plane. And then after we have to draw the plan and elevation in the first stage. So first of all, draw the XY reference line. Now here in this example also, we will use the first angle projection method. So if you are using the first angle projection method, the plan will be below the XY reference line, elevation will be above the XY reference line. And we have assumed that the base is parallel to the horizontal plane in the first stage. Okay, so the plan will be a circle. So draw the circle having a diameter 50 mm. Okay. Now divide the circle into 8 equal parts. Give the name of each point on the circle. Let us say that A, B, C, D, E, F, G, H, and the intersection point of all division is known as the apex point. So here we have also joined the apex point to the points on the circle to show the different generators. So you can say that the generators are imaginary line. So here we have shown 8 generators and the top view of the 8 generators. Now we have to draw the front view, and to draw the front view, first of all we have to take the projections from the base of the cone. That means from A. So here we will add A dash, B dash H dash, C dash G dash, D dash F dash, and E dash. Now connect A dash to E dash. This will be the front view of the base. So front view will be a line because right now the base is parallel to the horizontal plane and perpendicular to the vertical plane. So we will get the elevation of the base as a line. Now show the axis height equal to 80 mm. So we have to measure it from here. This will be our axis height perpendicular to the XY reference line equal to 80 mm. So here we will get the front view of the apex point. Now we have to join the apex point to the point of the base to show the required generators. So connect A dash to O dash, B dash H dash to O dash, C dash G dash to O dash, D dash F dash to O dash, and E dash to O dash, and we will get the front view. So this will be our final front view in the first stage. Now we have to derive the second stage, and here it is given that it is resting on one of its generators with axis parallel to the vertical plane. In the starting of this example, we have assumed that the axes are parallel to the vertical plane and perpendicular to the horizontal plane. So right now the axis of the cone is already parallel to the vertical plane. Now to derive the second stage, we have to take one of the generator on the XY reference line from the elevation, because here it is given that one of its generators, it is resting on HP on one of its generators. Okay, so we will take generator O dash E dash on the XY reference line, and we will copy this figure over here in the second stage. So by taking the generator O dash E dash on XY reference line, redraw this figure over here like this. Okay, so here we'll get A dash, B dash, H dash, C dash, E dash, D dash, F dash, and E dash, and O dash will be here. Now before deriving G cutting plane, we will draw the top view. So to draw the top view, what we have to do, we have to take the projections from the top view in the first stage. So draw the locus. This will be the locus of G, this will be the locus of H, A, E and O, locus of B and D, and locus of C. Now take the projections from the elevation, that means from A dash, B dash, H dash, C dash, E dash, D dash, F dash, and E dash. So here we will get A1, here we will get H1 B1, here we will get G1 C1, here we will get F1 D1, and here we will get E1. So these are the projections of the base. Now also draw the projection of the apex point over here. So here we will get O1. Now to draw the top view, we have to observe the condition, and here we can see that it is resting on one of its generator. So observer is going to observe this figure from this direction. Okay, so you can observe the base as a visible outline. So you will see the base from the top view. So base is going to be visible. So draw the base first of all. So base is going to be visible. Now draw the generators. So the generators O1 A1, O1 H1, and B1, O1 C1, and G1 are going to be visible. So first of all, draw the visible generators. O1 A1, B1, C1, H1, and G1 are going to be visible, while the generators O1 F1, O1 E1, and O1 D1 is going to be hidden in the top view. So draw the hidden generators O1 F1, O1 E1, and O1 D1. Now we will derive the cutting plane. Now to derive the cutting plane, we have to read this statement. It is cut by horizontal section plane. Now what is the meaning of horizontal section plane? A plane which is parallel to the horizontal plane, perpendicular to the vertical plane, is known as the horizontal section plane. So now the cone is cut by a horizontal section plane, and if the cutting plane is a horizontal section plane, then we have to show the cutting plane in the elevation. So now we have to show the cutting plane in the elevation. So the horizontal section plane passing through a point on the x is 55 mm away from the apex. That means in the elevation at a point 55 mm away from the apex point, that means measure 55 mm from the apex point over here on the axis and draw the cutting plane line over here. Okay, so cutting plane line is a line, or it is a chain line, thick at ends and thin elsewhere. Now after deriving the cutting plane, we have to derive the position of the observer to draw the section in the top view. So section is going to be generated in the top view, and we have to show the cutting plane in the elevation. So now observer is going to observe this figure over here from this direction. Okay, so we have to remove the part of the object which is in between the cutting plane and the observer. So we have to remove this part. So after removing this part, this figure is going to be look like this. Okay, to observe the section plane, we have to assume that the part in between the observer and the cutting plane is going to be removed. Okay, now the cutting plane is going to cut the cone at different generators and the base over here. So mark this point. Okay, this is P dash. Here we will get Q dash, R dash, S dash. Here we will also get T dash point. Here we will get U dash, V dash, because here we have two generators OB and OH. In the center we have two generators OC and OG. So here we have marked the 2 points, and on the base the cutting plane is going to cut the base at two places. Okay, in the front place and in the back place also. So here also we have marked the 2 points, but here we have only one generator, so here we have marked only 1 point. Now we have to project these points of the section plane in the top view. Now P dash is cutting the generator O dash A dash. So from P dash we have to take the projector, or we have to draw the projector up to the plan of the generator OA. So take the projector up to the plan of the generator OA. So here we'll get P. Now Q and V is cutting the generator OB and OH. So we will draw the projector up to the generator OB and OH. So here we will get on OB we will get Q, and on OH we will get V. Now here R and U are on the generators OC and OG. So we have to take the projectors up to the generator OG and OC. So here we will get R and here we will get U. Okay, at the intersection point of the projector and the plan of the generators, or the generators where the cutting plane is cutting the object. Now S and T are on the base. So draw the projection like this. So here we will get S and here we will get T. Now draw the section plane. So first of all connect T S, it will be a straight line. Okay, and now we have to connect all these points from T, U, V, P, Q, R and S with the freehand curve. So draw the freehand curve passing through these points like this. So this will be our sectional view. Now in the top view also we have to remove the part which is in between the cutting plane and the observer. So the part above the section plane is going to be removed. So the figure will looks like this. Okay, and now we have to draw the visible outlines which is going to be visible in this object after taking the section. So this part is going to be visible and the upper part is going to be removed. Okay, the upper part, that means from this cutting plane the upper part is going to be removed. So the part of A, B, H, C, G is going to be removed. A, B, H, C and G is going to be removed. Now in this part of the section, or in the section view, we have to draw the hatching lines, and hatching lines are the lines which are inclined at an angle of 45 degree to the XY reference line, and the minimum distance between two hatching lines should be 2 mm. Okay, so draw the hatching line over here in this figure like this. So we have to show the section by using the hatching line. So this is the sectional front view and the sectional top view. Now here the cutting plane is a horizontal section plane. That why we can also say that the sectional top view gives us the two shape of the section also. So this will be our final front view and the sectional top view. So this is it for today. Thank you for watching. See you in the next lecture. Till then, take care.